All right, so today we're going to learn about transformations of functions, so specifically translations. We've already learned about relations and functions, so now we're going to identify the effects of the graph by adding and subtracting values, positive or negative, but essentially what we are looking at and what this is called are transformations, well, specifically translations of functions. Here we go. There are parent functions. So that's the simplest form of any type of function. There's a whole bunch of them. The ones that we typically are going to look at are linear functions, which look like a line. So those are of the form y equals like mx plus b kind of stuff. You have radical functions where y is going to equal the square root of some number. And those are going to look like this. We have exponential, where the exponent is our variable. That's going to look like that. With your asymptotes, can't touch this. And then quadratics are the x squareds. That's the big U. So there are other types of functions, but these are the major ones that we're going to look at and mess with in class. So when you graph a translation, you are shifting. When you shift, you have two directions you could shift. You could either go vertically or horizontally. Vertical is an up and down shift. So kind of like the up and down y axis, that's exactly what a vertical shift does. It moves the y value. So those, when we look at them, are going to be outside of our function, our f of x or our y. A horizontal shift is going to be, oh yeah, along the x-axis. So that's going to move based on where the x is. Okay, so you have vertical, which is our f of x. And then we have horizontal, which is just the x value. So we're either moving left and right, up and down. For vertical shifts, we write all of our shifts outside of f of x. So what that means is if we have f of x, whatever we change is going to go right on the outside. If we are moving up, we are adding values. So if we move up 7, up means add. So our new function is going to say f of x plus 7. Ta-da! And then we would name it something like g of x, because now we have a brand new function because we moved it. If we move it down, we would subtract y values. So same deal. If we're moving down 1, we're going to take our f of x, whatever that function was, and we're going to subtract 1. And again, we have a new function, so we can call that h of x, j of x, whatever we feel like at the moment. Horizontal shifts. This is where things get messy, people. So you want to make sure you have written down in your notes to be careful. Take your time. Use the notes. When you see horizontal shifts left and right, you are writing them inside your f of x. So more specifically, you're writing them with the x value, because that's the part that we're moving. So if you are making a horizontal shift to the left, most people think subtract, because that's where the negative values are. Well, you actually don't subtract, you add. So a horizontal shift left 2 would say f And in the parentheses, you would write x plus 2. That would go left. Now, same deal, right? We have a new function here, g of x. Using the same logic, if we're moving to the right, logic tells us we should be adding. We're going to positive values, but horizontal shifts work counterintuitively. So we're actually going to be subtracting. If we move right 5 units, our new function is going to say x minus 5. So this is the one that usually trips people up, which means this is the one you might want to put a little extra thought into when you're doing these problems. Why does this happen? So it's all based on intercepts. So for a vertical shift, your parent function, y equals x squared, has a y-intercept of 0. So if we change that, y-intercept is 0. If we do a shift down 2, that -2 on the outside of our function right here, the graph ends up moving down 2. So our y-intercept changes. So that's why the vertical shift is pretty easy. A -2 moving down 2, a -2 y-intercept. For the horizontal shifts, this is where it gets a little crazy. The x-intercept, again, horizontal, x is also called the zeros or the roots. And the way this works is your x-intercept is 0 for your parent function, x squared. When we change the inside of our function, x minus 2, the reason our x-intercept is positive 2 is because 2 minus 2 equals 0. So when we have a shift of 2 to the right, which is negative, our actual intercept becomes positive. So that's the reasoning behind why this happens for the horizontal shifts and why it's such a big difference with the vertical shift. So now let's do some problems. Down here, we have a graph, y equals x squared. We're going to translate it, which means we are going to shift it up, down, right, left. Those are our options. We're going to translate it to make this other graph, y equals x minus 1 squared plus 2. So based on the previous notes, and now is a good time to actually pause it and look back at your notes. This plus 2 on the outside tells me we have to shift up 2 units. This minus 1 inside tells us we have to shift, it's horizontal, so you're going to go opposite of what you're thinking. We're going to move right 1 unit. Minus makes you think left, because that's where the negative numbers are on the x-axis, but we're actually moving right. So this 0.00 is going to move up 2, right 1. That's going to be our new vertex. And then from there, we have our new parabola. That parabola is not drawn to scale. Please don't judge me. So here's another problem. Same deal. Translate it. Let's get shifty. How are we going to move this baby? I have x squared, or not x squared. This is actually the absolute value function. I have a -5 outside the absolute value. -5 means I'm going to move down. So we're moving down 5. That +2 on the inside of the function next to the x tells me we're going to move to the left. So let's move it. We have our vertex 0, 0, left 2, down 5. There's my new vertex. So we're going to go that away. We're going to go that away. Like parent, like child. That's our new function. And we could do this over and over again. +1 outside means we're moving up 1 unit. -2 inside. That means we're moving right 2 units. So our vertex right here, we're going to go right 2, up 1. That's our new point. And then we're going to get jiggy with it. Ooh, that's it. So again, might not be drawn to scale, but you're going to have the same shape with the vertex shifted to another point. This problem is going to be a little different now. Okay, this problem a little bit different. So it says the function f is defined by f of x is the square root of x. Write down the expression for h of x. So what this means is the graph of f, the one that's in blue, is the parent function. And it's translated to get the graph of h. So that's our transformation. That's our new function. So we want to know, how did the parents move to get there? So the new function is h of x. And I know I'm going to rewrite it. Something's either going to go inside the parentheses, outside the parentheses. So starting with the parent function in blue, I can see this moves 1, 2 spaces to the right. That's horizontal. And a horizontal shift to the right means I put -2 inside my parentheses, inside my function. Vertically, this is moving 1, 2, 3, 4 units up. And a vertical shift of 4 gets written as +4 outside of our function. So the way we actually write this, because we know it's a radical function, we wouldn't write it with the f like that, although it's possible. We'd write the square root of x, and then that -2 would go inside the square root, and that +4 would go outside the square root. That would be the graph with the equation for f of x. So we'll try another one, similar, where we have the movement, and let's try to write the equation. So again, our parent function is in blue. That's x squared. And now we're going to move it to write k of x. So we have k of x, and I know it's some kind of movement that's related to f of x. So I'm going to write it like this, and then I'll just add the pieces afterwards. So from f, I'm going horizontally 2 units to the right, which means I'm going to have a -2 next to my x, x -2. And our vertical shift, 1, 2, 3 units up, so that's a +3, and the vertical is going outside of that function. Now, because this is a quadratic, I'm not writing f of x. I'm writing x squared. And that x is going to change. So k of x is going to be x minus 2 squared, and then plus 3 on the outside. So we can go from equation to graph. We can go from graph to equation. The only other thing that might get a little tricky is if you're already given the equation and something else is happening. So for example, this is not a parent function. This isn't a regular quadratic with just x squared. You already have some transformations happening. So the directions say the graph of f is translated down by 4 units. It becomes the graph of g. F of x, that's the one that's being moved. So this is our parent function. F of x is negative 4x squared plus 8. What is g of x? So here's what I know. If this is moving down, up and down, that's a vertical shift. And a vertical shift means I'm going to add or subtract something to f of x. So if I'm moving down by 4, then I'm going to take my function and I'm going to subtract 4 from it. Well, my function right here, negative 4x squared plus 8 is f of x. What I'm doing is I'm just subtracting 4 outside of the whole function to get my answer. Well, I can simplify these right here. 8 minus 4 is 4. So the new function is going to be negative 4x squared plus 4. So originally it's moved up 8, hence the plus 8. It's moving down 4. So your answer should really only be moved up 4 units in total. Let's try another one. Again, this is a good opportunity to pause and actually try this on your own now that you have all those notes. The graph of f is translated. So again, here we go. F is our parent function. What's up, parent? It's moving to the right 2 units. All right. All left. That's horizontal. And if you're moving to the right 2 units, that's going to say minus 2. So my function, h of x, is going to be f of x, that original function, but then my horizontal shift is minus 2. So what I need to do is I need to squeeze that minus 2 inside those parentheses. Minus 2. Nothing happens outside. So now this x minus 2 gets plugged in. So it's going to be negative 4. And instead of writing x squared, I'm going to write x minus 2 squared plus 8. That is my new function. Inside the parentheses, outside the parentheses, inside the function, outside the function. Hopefully this was good. You have enough notes to kind of go forth and do all the horizontal and vertical shifts that you need. So in conclusion, we went over translations of graphs. Translation is the shift, either vertical or horizontal. Vertical goes up and down. Horizontal goes right and left. And that's it, y'all. Now you can try it by yourself and see how you do. Good luck. If you need anything, you know how to reach me. Bye.